Hello everyone, welcome back. So we'll continue with the troubleshooting um, series in this 300 series. Specifically in this video we'll focus on how to downsample your data. So if you collected your data at your kinetic data at 1000 Hz and you want to run some calculations that needs to have the same sampling frequency as your motion capture sampling frequency, then you want to downsample your data. So, and if you want to downsample data for any reason, this is the way to do it. So, let me just save this quickly, and then there are three ways to downsample your data. It's not straightforward. There's no specific pipeline command that Visual 3D created to downsample your data. So you have to be creative and think outside the box. All right. So the first method that is unofficial is through this. Now, as is mentioned here, note as of February 2017, this is still a hidden and unsupported command. So as I mentioned, Visual 3D did not write a specific command to do this. So what you need to do is you need to copy paste this command here and copy it and paste it in. You have to have a specific pipeline in like any command here, like for example like this, and then paste it like I mentioned. As long as you paste it and write a specific command, Visual 3D will understand that, and then paste it. So then once you have it here, you can modify it. So I already like have it, so I'm just gonna remove this and I'm gonna edit here. So what you need to do, for example, if you the downside of this specific method is that if you use this method, it will override your actual saved your actual like original data. So that's the downside of this method, but it does work. So if you need like something quick, this will do the job. So old file name, you just need to type the file that you want in here. So I'm just gonna, if you remember, once you put the asterisks, it will make your life much easier, and we'll call that certain um, file that you want. Alright, so I put that here, so it should call this first trial, and then signal type either analog, so it can only downsample the analog data or the target data, so your kinematic data. So if you want to downsample like the actual force data here, you can't. So you choose either like analog or target, and then you put the new analog rate. So if you're gonna use the point like the target, then you just use this. So for the analog, because I sampled the analog for like in the 1000 rate frames per second, and the kinematic data at 100 frames per second, I'm just gonna choose 100 frames per second. So I'm just gonna keep it like this, and we're good. So when I step this specific pipeline, if you see here the analog, there is the original analog data. So if you go to any force plate, like force plate 6 for example, Z, or force plate 5, you see when we plot that here like force plate 5Z, or when we look at the actual data, you'll see that the frames in here are all the way to like 490, because that's the frame rate of the motion capture. But you'll notice here that you'll have all these subs. So the way that it works in motion capture is that when you choose the specific frame rate for the motion capture, the way to choose your kinetic motion capture frame, the kinetic frame rate is basically a multiplication of your kinematic or motion capture frame rate. So that's why it has the first column here is always the motion capture frame rate for the kinematic data, and then all the additional columns in here are the additional data that are used as a multiplication. So I collected 1,000 frames per second for the kinetic data, and here it's just basically a multiplication. So you can only choose 10 times 100, to get 1,000 frames per second. If you want to collect at 800, then you just choose 8 times your motion capture. So you see that we have all of this data in here, but when I run the the actual command in here, what it will do, see, like it shows that file that I chose, and then if you go to the original, what it did basically, it kept the old process, so that's why it gave it a name of old and an underscore. And you see the data here are still like sampled at 1,000 frames per second. And you see like here, when you go to data graph, you see the frames per second is 1,000 hertz. But when you go to the original data here and choose again the FP7, you see that the frame rates per second now is 100 and not 1,000. And when you go to the actual data, it only goes to 490 frames, and basically deletes all the other columns. So, like I said, the downside of this is that it basically deletes your original data. The other method to use is, it's not, again, it's not recorded, or it's not a method that Visual 3D uses. This is a method that I came up with, and I did a lot of outside thinking of the box. So basically, if you remember from one of the previous videos, you can create any vector you want. So when I wanted to create, when I want to downsample the data, technically and theoretically and mathematically, we can downsample the data by choosing only the first column. If you remember, just let me reload the actual files that I was working with, and let's go back to the same one, and then we choose, like, again, the original data, either like the analog or the actual, like here, the actual force plate data. But technically, theoretically, and mathematically, because the first column is the column that is used as the frame rate of the motion capture, so the kinematic frame rates per second, we can create a vector with that only uses the first column, and it should be the same frame rate as the motion capture. So if you go to the official Visual 3D wiki motion that talks about analog, so if you just type analog data type in C motion, it will give you like the specific instructions on the analog data. So the reason why I brought this up is because here they talk about that. So Visual 3D data view dialog displaying the analog signals. So the first column of each component in the row in the data window is displayed as the motion capture rate. And if the analog signals are collected at a higher rate, which is usually the case, then there are multiple values of the analog signal for each motion capture frame. The column heading sub 1, etc. refer to the subframes with respect to the motion capture rate. For example, in the figure above, the first 3 columns of data are the XYZ components of the analog frame that is synchronous with the video frame. The next 3 columns are the subframe, and so on, just like I mentioned here. So if you technically, if you want to just get the frame rates and downsample the kinetic frame rates to the same frame rates as the motion capture, you can do that by only taking the first 3 columns, like the first column for the X, and the second column for the Y, and the third column for the Z. But when you try to do that, when you try to like hard code it, It actually does not like that. So for example, let's do that now. For example, like let's name this FP5 mocap hertz, and then we try to create a vector with let's say this force plate for FP5 force, then two columns and original, two columns, and then FP5 and two columns. You have to specify the actual coordinates, you know, so x or y or z. So let's try x, and then in MATLAB, if you want to like choose all the rows and then one column, or like all the columns and one row, you basically need to open up brackets and then type colon and then comma and then 1 if you want to choose all the rows for the first column. And here in Visual 3D you need to like type square brackets, and then instead of like a colon you just use you type -1. -1 means all the whatever frames or columns or rows, whatever you want. But obviously the first section is always the rows and the second section is the columns. So -1, and then we want to use the first column, and then we do the same thing for, and then every time you want to add another like column to the vector, another like coordinate system, whatever, to that specific vector, you just put a comma. So comma, we do the same thing for y, and then comma, we do the same thing for z. Technically this should work, but let me just make sure we, yep, okay, it's fine. Alright, so when I hit step, first of all, it did not like this. It did not create, see, it says here derived kinetic FP5 mocap hertz was not created because there is no results. Let's see what the problem is here. Vector force original FP5 X. Vector force original FP5. Oh, okay, this is why. So it has to be brackets. Yeah, that's the problem. So I close it with a normal bracket. You have to always make sure that you're double check your codes to make sure you didn't miss anything. So when I step it now, it will run it, but the problem now, so you see like it didn't give us any errors, but the problem when we go to our data here, it does not actually downsample it because it thinks that although these are additional columns in here, it only actually sees it as one column. That's why when we choose like when you choose in the code here like all of the frames, it actually sees all the frames in the kinetic data or analog data frame rate, so 1000, because it sees that as one column but not 10 different columns. So that's the problem here. But if you want to do it, if you want to hard code it, there is a way to do that, and you do this way. It's not ideal, but it does work. If you want to just downsample a few things, what you need to do is basically choose the signal you want, so like FP5 in here, and what you need to do is add any kinematic signal, like any signal that has a motion capture frames per second, so the hertz, and then basically add it and then subtract it from its own. So here what I did is I added the center of mass and then subtracted the center of mass from here, and it does work. So I did that same thing for the x, the y, and z. So basically I created the x here, so you see fpx and plus the center mass minus the center mass, and then closed it and added the comma, and then did the same thing for the y, and then did the same thing for the z. And I gave it like a center mass, so you know it doesn't matter really, but it's gonna give you the same. So let me actually give this change this name to mocap. Let's see, I'm just gonna add frames per second like this, 100 frames per second. So I'm gonna run this, and then we'll see the difference. So this goes all the way to 49,000 frames, so it's 10 times the mocap frames. So like 490, you see it here, 490 frames, but it's actually 4,900 frames in the kinetic sampling frequency. But when we actually go and do the second method, you'll see that it actually uses the mocap frame rate. And when we look at the actual data, so for example, like the x value here is -13, the next frame is 3, the next frame is -2. So when you look at the actual data, the raw data here, and we go to the first frame, and remember the first column is the mocap frame rate. So you see like -13, 3, and -2. So it's actually correct. And we look at the y is -9, -32, -56, and when we go here, we'll see also the same values. So -9, -32, -56. So it does work, but it's not ideal, and it does consume time. The third method is actually to export your data from Visual 3D to MATLAB and do everything in MATLAB, and then import the data back in Visual 3D. So this is a very helpful tool to not just downsample your data, but run anything and any data, any processing, any analysis you want. And if you want to keep analyzing data in Visual 3D, then it's a very helpful tool to import your data back in Visual 3D. But obviously you can export your data and just do anything you want in MATLAB. But this is a very powerful tool to run any other additional analysis that you can't run in Visual 3D and MATLAB, and then import it back in Visual 3D. So with that, I'm going to conclude this video, and the next video will just dig deeper on how to do all these analysis in MATLAB. Well, thank you so much, and again, if you have any questions, always let me know. Thank